Alright, y'all, this is section 10.6. We're going to be talking about tangent lines today. Alright, so we're starting to wrap up unit 10 on circles. So we have next the tangent line. So a tangent line is going to intersect a circle at exactly one point, and that one point is called the point of tangency. Alright, so we look over here at this figure. My tangent line is going to be line AB, but the point of tangency will be point A. So that'll be my point of tangent. Now, property of a tangent line: a line is tangent to a circle if and only if it is perpendicular to a radius that is drawn to the point of tangency. All right, so all that being said, a few things to remember. Perpendicular means we're talking about right angles are being formed. So we had center point P, and we have this radius AP, that segment right there, being a radius. So because line AB is perpendicular, meaning it creates a right angle with radius AP, this is enough for me to know that it has to be a tangent line. Now, let's talk about this next section right here. Determine if AB is tangent to circle P. Now, the way that these pictures are all drawn, it definitely looks like line AB in each one is a tangent line. But keep in mind, tangent lines can look a certain way, but in reality, could I actually draw this figure and it looked like this? If I had a circle with a radius of 8 and I had a few other sticks with lengths of, let's say, 15 and 17, could I actually make this, or am I just putting numbers and typing them onto a page? Well, if we're trying to determine if it is tangent, then basically that would mean that we'd need a right angle to occur right here where the radius PA meets the potential tangent line AB. And therefore, what it looks like is we create a right triangle with side lengths of 8, 15, and 17. So the way that we're going to determine if the line AB, which for us is actually going to be the blue line, or at least for this first picture that I just drew, if we're going to determine if AB is actually a tangent line, we need to determine if the picture satisfies Pythagorean theorem. Well, Pythagorean theorem, we need to remember what that is. Pythagorean theorem states a squared plus b squared has to equal c squared. If we have three lengths that meet this property, then they make a right triangle. Now, usually we have two of them and we plug them in and we'll find the missing side. Here we have all sides. So basically all we're doing is we're checking to see if when we plug these in, so a squared will be 8 squared, b squared will be 15 squared, and c squared will be 17 squared. We're checking to see if we get a true statement from this. Well, whether you type in the 8 squared and the 15 squared individually or all together, let's say if we do it individually, this becomes 64 plus 225 and 289. So the question that I'm asking myself is this a true statement? Does 64 plus 225 equal 289? And if you type that in, you're going to see that yes, these two do equal each other. So what that means for us is that AB is a tangent line. So we used Pythagorean theorem to determine basically, could we create this shape in reality? Or is it just us putting a picture on there and typing in some random numbers? We could create this actual shape. All right, let's try another one. Let's try number 2. All right, number 2. Now, with this one, this picture is gonna be a little bit misleading, so we got to keep something in mind here. I'm given side lengths again, so I have side AP. This was my radius. It is 11. I have side AB. This is my potential tangent line. And then I have side BP right here. Now, currently, it looks like BP just has a length of 5. But remember that the 5 is only for the part that juts out of the circle. The part that is inside of the circle is a radius. so that means that it would be another 11. So the entire side length BP is 16. Okay, so make sure you catch that with problems like this. So the 5 is just for the part that's outside the circle. You add that to your 16. So once again, we're trying to determine if my line AB, the blue line, is a tangent line, which basically means could we create a right triangle with a radius of 11, or excuse me, a circle with a radius of 11 that has side lengths of 14 and 16 and it all come together. Well, let's check this one once again. 11 squared plus 14 squared has to equal 16 squared. This is the question for this one. Well, again, if we do it individually, we get 121 plus 196, and we're asking ourselves, do these two add together to equal 256? Well, if you type this in, you're going to see that no, these two do not add together to make 256. So what that means for this one is that AB is not a tangent line. Basically meaning that if I was to try to recreate this shape with actual circles and lines, I wouldn't be able to. The pieces would not fit together. All right, let's keep going. All right, next section is asking us to determine, or we're assuming now, if JK is tangent to circle L, find the value of X. Okay, so JK in every single one of these is a tangent line. We don't have to go through and prove it. So I know that means right here, where J meets the circle, we should have a right angle. Well, just like the rest of them, if it's tangent, that means we should be able to create a right triangle. And so if we take a look at the pieces that we have, we'll have 7 squared plus 19 squared. And since X is referring to the entire length and not just asking us about a part of it, we know that it's going to be talking about X squared. All right, so we put all these stuff together. I can type all this in at once. 7 squared plus 19 squared is going to equal 410. 410 equals X squared. Square root it. We'll round it off to 1, and we'll say X is about 20.2. All right, let's keep going. Number 5. All right, so for number 5, once again, we're assuming that JK is tangent, so that means we should have a right angle right here. I've got two side lengths at the moment, 10, 24. Now, this time, they're being a little bit more particular. So notice last time, when they wanted X to mean the entire thing, they added these little extra things out here, these extenders, to show that X is not just the part outside of the circle, but the whole thing. Here, they don't give us that. So what we can assume for this one is that only this part is X. Just the part that shoots out from the circle. Now, what does that mean for us? Well, that means that the extra bit has got to be a radius. So this extra bit has to be 10. So we are still solving for X. We are still solving for the entire length, KL. But we'll just have to do it a little bit differently this time. So we're going to set up the exact same way. We have the two legs, 10 squared plus 24 squared is equal to, now just for clarity's sake, I'm not going to say X squared. I'm just going to say we're solving for C squared, since C is what we would usually use. All right, so if I put all this together, 10 squared plus 24 squared would make 676, has to equal C squared. Take the square root of both sides, and I'm going to get that 26 equals C. So this entire thing is 26. So the entire thing is 26. It's split into two pieces. Remember, we talked about way back in Unit 1, the segment addition postulate, piece plus piece equals whole. So something plus 10 makes 26. X has to be 16. All right, next one, number 7. So once again, we're trying to prove that JK is a tangent line. So we have a right angle here. Now again, with all of these, we are making right triangles. Now this picture is a little bit different, but we can still use this one for sure. So I am still solving for KM. So this time it is talking about the entire length. This is my hypotenuse. Once again, this is my C side. But keep in mind, the 3.5 that they're referencing is only for LJ. But LJ is not making up the triangle. We need the entire thing, MJ. And since LJ was a radius, that means ML would be the same length. So this entire side, JM, will be 7. So when I set up Pythagorean theorem this time, I'll be using 7 squared plus 6.4 squared is equal to x squared. All right, so putting these two together, and we're not going to round. We're going to use the entire thing, and we'll round at the end if we have to. So 89.96 is going to be equal to x squared, square root both sides, and we'll get x is 9.5. Again, one thing to check for whenever you're working this thing out, make sure that if you are solving for the hypotenuse, it should be your longest side length. So we had a length of 7, a length of 6.4, and I know I'm solving for the hypotenuse because it's across from my right angle, then that side length should be longer than the rest. All right, now I'm going to take a quick break from the notes to say this. If you have made it this far in the video, here's what I want you to do next to prove to me that you did. I will give you 10 bonus points on your lowest test grade from the entire course. If you email me right now this magic phrase, Mr. Donahue is awesome. Now here's the thing. I do not want you to tell your friends this, the ones who are over there sitting in the corner, not on their laptops, they're on their cell phones, they're playing some kind of game, whatever. They're just talking, maybe they're sleeping. I do not want you to tell this to anyone else. This is for you because you are doing what you're supposed to be doing and watching the video. So again, 10 bonus points on your lowest test grade. You are going to email me right now this phrase, Mr. Donahue is awesome. Now, I will only be accepting this phrase when it is your class period. So if you're in second block right now and you email me this message anywhere between, let's say 9:38 through 11:12, then you'll get your 10 bonus points. If you email me afterward, then I'm going to assume one of your friends told you, and that's not going to work. If you're in fourth block, you're going to send me Mr. Donahue is awesome anywhere from 1:18 all the way to 2:52. Anytime outside of that time frame, I will not accept it. All right, let's get back to it. Number 8. So number 8, still same deal. We're trying to determine if JK is tangent. So I'm going to put my 90 degree right there. So I've got a leg length JK is 7. We'll say this is my A. I'll do red right here. Now this time they do give us the hypotenuse. So this right here is across from the right angle. This is my C value. It should be my longest side. Now here's the thing. JM is B, but X is only half of that. So we're going to solve for B first because that's what helps create the right triangle, and then we'll just half it. So we set this thing up. 7 squared plus B squared equals 25 squared. All right, so we get 49 plus B squared equals 625. Gonna move my 49 over. B squared is 576. Square root it. B should be 24. And so B, the whole side length was 24. It's the diameter. X is the radius, so it's half of that. So final answer here, X should be 12. All right. Let's look at this next little section. So a few other things to note about tangent lines. So let's say if you have a circle with 2 tangent lines. So in this case, we have lines AB and CB. So if you have 2 segments that shoot out from the same external point and they wind up being tangent. So we're saying that if the lines started here at point B and they both shot out, one hit at point A, the other hit at point C, and they became tangents. So they created right angles. then these two lengths have to be equal to each other. And then another thing to note, so if a polygon is circumscribed around a circle. Now what this means is that if a polygon is circumscribed, that means that every side of the triangle should be tangent to the circle. So we had triangle AB. So we had side AB. It met the circle at point D, and it became tangent to it. We had side length BC, met the circle at point E, and became tangent to it. It hit it once and it went away. Side AC hit the circle at point F, and again, it's tangent to it. Then what that's saying is that all these sides will be tangent, and what it's basically going to do, as you can see, is that just like with the last property, so for example, the two parts that are shooting out from point A, both are equal, 1 tick mark each. The two parts shooting out from point B, both equal, 2 tick marks. The two parts shooting out from point C, both equal, 3 tick marks. All right, so let's work out just a few more problems and we will be done with this section. So here we go. Directions tell us to assume that segments appear to be tangent are tangent. All right, so number 10. So we are to assume that at point A and at point C, these two segments are just hitting the line and not going through it. So these would be tangent. So both of these tangent lines, AB and CB, are both reaching out to the same external point, point B. So according to the property we just talked about, that means these have to be equal. So if I'm finding x, I'm going to set these equal. 5x plus 23 equals 8x minus 19. We work it down, we're going to get x is 14. All right, let's look at 12. All right, so number 12 right here. So number 12, we are looking to find the length of SV given all the other stuff that we have right now. Well, let's start with the first thing. So we can assume that ST and SU are tangent. We're told to assume anything that looks tangent is tangent. Now what that means is that these two have to be equal. 10x minus 41 equals 4x plus 7. We work this thing down, we're going to get that x equals 8. Now, if I'm trying to solve for SV, which is this middle line, well, let's say I take the top triangle that I've just created because I've got side lengths. So if I want to figure out what ST is, I can plug that back in, and I'm going to get that ST has to have a length of 39. I'm trying to figure out what SV is, so I'll say that SV is my x. So I can set up my formula now of where I have 17 squared plus 39 squared has to equal x squared. All right, so when I do these two together, 17 squared plus 39 squared, I get 1,810. And then I can square root both sides. I'm going to get that x has to be 42.5, and that is going to be my entire length for SV. Don't worry about that part. I accidentally wrote that in. So SV will be 42.5. All right, let's do this last one real quick. Number 13, find the perimeter of triangle DEF. So we have a polygon, a triangle has been circumscribed around the circle. And so again, we're looking at, so we have point DE, or segment DE, hitting the triangle at point H. Segment DF, hitting the triangle at point G. Segment FE, hitting the circle at point I. Now, just like with that last property, if I have tangent lines that are meeting at the same outside or external point, that means that those tangents are equal in length. Now, what that means is if I have right here, from H out to E has a length of 16, and I is also going out to E, then that means that it also is 16. If from point I out to point F is 9.5, and G to F is also going out to the same point F, then it also has a length of 9.5. And then same to here, then obviously, D to H will be 11 because D to G was 11. So if I want to figure out the perimeter to this, I'm going to add up all of my side lengths. Well, I have that the top side, DE, is 27. FE, that's going to wind up being 25.5. DF is going to be 20.5. So perimeter, we just add them all up, and we should get perimeter of 73.